Okay, so we're going to use models to multiply decimals today. So before we get started, let's start one more problem. It says Natalia bought 3 pounds of oranges and 2 pounds of apples. Oranges were on sale for 15 cents less per pound than the apples. The apples cost 95 cents per pound. How much did Natalia spend on fruits? So on your whiteboards, the first thing that we're going to have to solve is what? What's the first thing we're going to have to solve? Which is not the first problem that we're going to set up. The first thing that we have to solve for is what? How much the oranges are per pound. Then we have to figure out how much she spent on the oranges and how much she spent on the apples, correct? Okay, so you're working on that? On your whiteboards when you have your answer. Okay, so let's walk me through this. It says Natalia bought 3 pounds of oranges and 2 pounds of apples. Oranges were on sale for 15 cents less per pound than the apples. The apples cost 95 cents per pound. How much did Natalia spend on fruit? So what's the first thing I have to do? First thing I have to do, Jeremiah. Yes, Isaiah, I'm talking to you.
I don't know.
You don't know the first thing we have to do?
No.
No? Luke, what's the first thing I have to do?
95 minus 15.
95 minus 15, which is find out what?
80.
No, what is that telling me?
You find out how much, because it says less per pound the apples, so it's 80.
So I need 95 cents, subtract 15 cents. Alright, 5 minus 5 is 0. 9 minus 1 is 8. Here's my decimal. So I have 80 cents. So how much are the oranges? How much are the oranges? 80 cents per pound, right? So now it's the next thing I have to do. Seabass. So I need 80 cents times 3. 3 times 0 is 0. 3 times 8 is 24. 3 times 0 is 0 plus 2 is 2. I have 2 decimal places, so I need to go 2 decimal places. Alright, so that gives me $2.40. Next thing I need to do. Hess?
95.3.
Why? What's 2 pounds? So now I need to find out how much you spent on apples. So I know how much you spent on oranges. How much you spent on apples? Well, that's 95 cents a pound. And she bought 2 pounds. 2 times 5 is 10. 2 times 9 is 18. Plus 1 is 19. 2 times 0 is 0. Plus 1 is 1. $1.90. Because I have 2 places here, so I have to move in 2 places. So now what's the last step I need to do? Alright. So I need $2.40 plus $1.90. 0, 3, carry my 1. How much did she spend? $4.30. That's how much she spent. Alright. We're getting into our examples. Everybody should have their textbooks opened up to page 397. We're going to find 3/10 times 7/10 using a decimal model. So we're going to use one 10 by 10 decimal model. All right. Oh wait. Okay, so last year you guys worked on finding area things. Basically, we're going to find the area of this decimal model. Okay, so we're going to use 1/10 by 10 decimal model. We're going to shade a rectangle that is 3/10 of a unit wide and 7/10 of a unit long. So if you count the squares here, how many squares are there? No, go just in one row. 10. Do me a favor, open that door. Okay, so there's 10. So we need to shade how many? What's our first number in our problem? 3 what? So how many out of the 10 do I need to shade in order to make 3/10? 3. So there's 3. Okay. Then I need to go 7/10 unit long, right? So down here on the bottom, it also has 10 units. How many of those units do I need to shade?
7.
Now, in the corner I already have one shaded, correct? So I'm going to start from here, and that's going to be 1, 2, 3, 4, 5, 6, 7. So then I'm there. Okay? Now what they want you to do is basically the area. So we're going to fill in the rest of this. There. Okay? So how many squares did I fill in? 21 out of how many? Right. So there are 21 hundredths in the shaded region. The shaded region represents the area of a rectangle with a length of 7/10 units and a width of 3/10 units. So 3/10 times 7/10. How do I write 21 hundredths? How do I write 21 hundredths, Isaiah?
I don't know. I don't.
Morton?
2.1.
That would be 2 and 1/10. I want to write 21 hundredths. Walker? 0.21. So we're going to put a 0 there, but yeah, 0.21. So decimal, right? There's a decimal. Tenths place, hundredths place. 21 hundredths. Okay? Oh, this is going to be tricky. Now we're going to find 4/10 times 2 and 4/10 using the decimal model. Okay? You can see things are going to get a little bit more difficult. So they already have it laid out for us, so all we have to do really is shade it in. But we're going to talk about it a little bit. First one, just like the last page, we're going to shade in 4 out of the 10 in one of the rows. Okay? So here's 4 out of the 10 in one of the rows. Now our next number says 2 and 4/10, right? How many squares does it take to make a complete unit? Yes, sir. No. We're only talking about rows and columns right now. Struggling? 10. So if I have 2 and 4/10, I have to fill in how many completes? Yes, Sammy? Huh? No? Alright. How many units did we say it takes to make one? How many? 10, right? Now, how many ones do we have? How many ones do we have in our problem? 4/10 times 2 and 4/10. How many ones do we have? Yes, ma'am.
2 and 8 tenths.
Huh?
2 and 8 tenths.
Not 2 and 8 tenths. I'm looking for just the ones now. How many ones are there in my two numbers that I just told you? Frogman.
10 or 2.
Huh?
2.
2. So that means I have to fill in 10 units for the first one. There's 1. 10 units for the second one. There's 2. And what's left? 4 tenths, right? So I need 4 more squares. And there they are. And once I've done that, I need to shade it in just like I did on the other page. Shade in the entire area. Now, each one of the squares that I just shaded in represents how much? How much are each one of the squares on? Yes. No, not 1/10. Now we're looking at the entire cube, the 100 cube. So 1 square in 100 cube is what? What? It's 100. Okay? Now, how many of these do I have filled in? How many did I color in? How many did I fill in across the bottom? How many did I fill in across here? Huh? 24, right? So 24 across the bottom, so that's 24. I add 24 more, that's what? 48, and then I add 24 more for the third row. So this is 24, 48, this would be 72. And then my last row would make it 96. Okay? So we're going to have 96 total units. 96. And each one of these is worth how much did we say? 100th, right? So that's 96 over what? 100. Now, this is where it gets tricky. There are actually 300 total boxes, right? But each one of the boxes within that 300 are only worth 100. So the number shaded goes over 100. Okay? So we shaded a rectangle that was 4/10 units wide and 2 4/10 units long. Okay? So when we're the actual decimals of the problem, we're going by tens. So it takes 10 units to make a complete whole. And after that, we're going by hundreds when we're actually putting them together. Now, it says shade the same amount of squares on a 10 by 10 grid. So here's our 10 by 10 grid down here, right? So it's telling us to shade in our 96. And I shaded in what's in it. I fixed it. There we go. I fixed it. So there's 96 total. So there are 96 hundredths in the shaded region. So that's 0 and 96 hundredths. Okay. So far, so good. You guys understand what we're going to be trying to do in our homework today? Yes? Fantastic. So there's our first one. And there's our second one. Alright, so how are the equations 3 times 7 equals 21 and 3/10 times 7/10 equals 21 hundredths similar, and how are they different? Talk about it. Figure it out within your group. How are they the same? How are they different? All right, Isaiah, say that again, please.
They're both the same. One just has a decimal.
They're both the same. One just has a decimal. So they both contain the same digits, is what you're telling me. Right? The same digits. And then you said that one has a decimal.
Am I done getting fixed?
I would have said that 7 times 3 in the first one equals 21, and 7 times 3 times 7 in the second one equals 21. And I would have said that in the first one, how many decimal places are in the problem? How many decimal places are in this problem that I just put a square around? 0. How many decimal places are in the answer?
0.
How many decimal places are in this problem that I put a square around?
0.
2. How many decimal places are in my answer? 2. So I would say that the problems and answers have the same number of decimal places. All right. Our next one, it says, use math tools. How is using a model to multiply 3/10 by 7/10 similar to finding the area of a rectangle? How is it similar to finding the area of a rectangle? First of all, can anybody tell me what the formula for finding the area of a rectangle is? No? Just length times height? I would have said length times width, but that's correct. Alright? So length times width. So let me see here. Insert page. Okay, so I put some graph paper up here for us so we can look at this. So let's say I have a rectangle that is 3 inches by 3 inches long, and what other number do they have us using? And 7 inches wide. So I would go 3 inches by 1, 2, 3, 4, 5, 6, 7 inches. There's my rectangle. Now the area of this rectangle would be the area that is inside of the rectangle. So who can tell me what the area of my rectangle is? What's the area of my rectangle? How many square inches? What's that? 21 inches squared. So, how is that similar to what we just did? Is why? Yes. What is each one of these? One what? In here it's 1 inch squared, right? So it's a unit of measurement. When we're doing this, each one of those squares that I just made is 100. Okay? So we're modeling the units of the answer, the units that make up the answer. Okay? And in one, it just so happens that it's the unit squared, so the one I drew was inches squared. Okay? So it was inches squared. And on this one, each one of the units that are shaded equals 100. So it's the same exact idea, it's just that one is representing the square units and one is representing a fraction of the whole. Make sense? However, the math is still the same. We're going length times width. We're modeling it as a rectangle, so it's length times width. Alright? So now, you guys have plenty of time actually. So we've done that. You guys are going to work on 3, 4, 5, 6 and 7, 8 and 9, 10 and 11, 12, 13, and I believe that 14 will be the last problem. And there you go. So there, all of your answers will be available where? Make sure that you show your work.